Hi everyone, in this video we'll be covering the physical and chemical properties of bases and alkalis. At the end of this video, you should be able to state the physical properties of bases as well as to state some of the reactions they undergo. In addition, you'll be covering the test for ammonia gas as part of one of the reactions of bases. A base is any metal oxide or hydroxide that reacts with an acid to produce salt and water as the only products. Examples include sodium oxide, sodium hydroxide, magnesium oxide, magnesium hydroxide. So we are referring to metal oxide or metal hydroxide. You may be wondering, how does this term base actually come about? So in the 1700s, people reacted acids with this particular substance that resulted in the formation of a solid material called a salt. And they called it a base because it serves as the base for the salt to grow out of. Because of that, that term was born and it has been used up to this very day. An alkali is a special type of base that is soluble in water and therefore produces hydroxide ions. Okay, so like an acid, an alkali undergoes the process of dissociation. So if we were to look at a Venn diagram, all alkalis are bases, but not all bases are alkalis. So sodium hydroxide is a base. It is also an alkali. Okay, copper 2 oxide, because it's insoluble in water, it is a base, but it's not an alkali. Okay, so alkali must be something that is soluble in water. Sodium oxide is considered an alkali because when you add it to water, it dissolves in water to form sodium hydroxide, which is also an alkali. Okay, so take note, for your oxides that are soluble in water, they actually produce the hydroxide, okay, which is therefore the alkali. So over here in the table, it shows you some common names of bases that you can find around you. Okay, so slick lime refers to calcium hydroxide in the solid state. Lime water, you'll be familiar with this, calcium hydroxide dissolved in water, so it's AQ. Quicklime, calcium oxide, limestone, calcium carbonate. So carbonates are not bases, but take note, I've put it here because you notice that many of the calcium compounds have very unique household names. Then we have caustic soda, sodium hydroxide, and caustic potassium hydroxide. Over in this table, it summarizes examples of bases that are insoluble and soluble. Those soluble ones we call alkalis. Bases in the form of metal oxides as well as metal hydroxides. So there's an example for each of them. There is an unusual example of a base or alkali, which is aqueous ammonia. So aqueous ammonia, when you add it to water, undergoes dissociation as well to produce your hydroxide ion. Do you find this symbol familiar? For those of you taking pure chemistry, you will notice that this is the double-headed arrow, which actually tells us that it is a weak base. Okay, we'll talk a little bit more about aqueous ammonia later on. There are some physical properties of alkalis that we must be familiar with. The first is that they have a bitter taste. Of course, we don't taste alkalis in the lab, okay, so don't do that. They feel soapy. So in the lab, right, if you ever spill some sodium hydroxide on your hand, you'll find that it is very slippery in nature because the oils on your skin contain fatty acids. So what happens is that the sodium hydroxide actually breaks some of the bonds, producing molecules that are found in soap. Okay, that gives us that soapy kind of feel to it. Alright, so if that happens, just quickly wash your hands, as alkalis can be an irritant to your skin. Like acids, when they dissolve in water, they form mobile ions. So example again, your NaOH. So your mobile ions are responsible for electrical conductivity. Okay, and like your acids, right, instead of H+, the OH- ions are responsible for the alkaline properties of the base or alkali. Last but not least, they turn your red litmus paper blue. You can find many bases in your everyday life. Okay, one of it is milk of magnesia, okay, which is used to treat heartburn, for example. And another one which I have here is you can actually get it from the pharmacy for relief of gastric pain. Alright, and if you look at the ingredient list over here, I'm not sure you can see very clearly. Okay, it says that it contains aluminum hydroxide and magnesium hydroxide. Okay, so my question to you, would you classify aluminium hydroxide as a base or an alkali? What do you think? Okay, maybe I pour some out for you to take a look. So if you recall your solubility table, right? Aluminium hydroxide and magnesium hydroxide, they are insoluble in water. Okay, so it is a suspension. So what it does is it kind of neutralizes some of the excess acids in your stomach. Yeah. So by itself, if I were to add universal indicator, it will have a pH that is above 7. Okay, because it's a base. Okay, so it's a bluish green color here that you can see. Okay, so the base neutralizes the acid in your stomach. So you can see here, universal indicator turns red. Okay, now I will add the suspension over here. Okay, it will react with the acids in your stomach and neutralize it. It becomes green already. Yeah, I think not very clear here. Let me add a bit more of the indicator. Okay, a bit more indicator. You can see that originally the acid turned the indicator red, right? Now by adding the suspension, the acid has been neutralized. Okay, so this is how the antacids actually work for relief of gastric and heartburn and all this. Yeah. Okay, so over here, you notice on the box they say anti-flatulent, right? Okay, so there are certain antacids that are carbonates in nature. So carbonate, when they react with acid, produce carbon dioxide gas. So if you take these carbonates, right, it may cause bloating in your stomach. Okay, and results in flatulence. So when you use a base instead of a carbonate to neutralize the acid, then you do not produce any gas, and therefore it does not have the symptoms of bloating. Yeah, so there are different brands. Okay, so for example, Gaviscon, right? Gaviscon actually uses calcium carbonate to neutralize the acid, but same function. What you have seen here is a case of neutralization. So neutralization is when you have an acid reacting with a base to form salt and water. One way you can remember is that we can use always become someone wonderful. The cation comes from the metal hydroxide, and the anion depends on the acid. Okay, so if you use potassium hydroxide, you have potassium something, nitric acid will be something nitrate. Pause the video, you may want to try to write the two equations over here together with the ionic equations, and I'll go through that with you in a while. So for the first one, you get H plus OH minus gives H2O. Yeah, you will notice that this equation keeps appearing, right? So for many of the neutralization reactions, this is actually the ionic equation for neutralization. If you look at the learning outcomes at the start, you will notice this statement. Yeah, so the ionic equation for neutralization is always written like this. Okay, for acid and alkali. Alright, for the second one, take note, magnesium oxide is a base because it is insoluble in water, so we do not split up magnesium oxide. This type of reaction between an acid base is known as neutralization. Okay, so make sure you know. And neutralization is a reaction that produces salt and water as the only products. So if you look at the example below, both involve an acid and base. But for the second reaction, reaction number 2, because it produces additional chlorine gas, that is not considered neutralization. So the second reaction involving bases or alkalis will be that with ammonium salt, and this produces ammonia gas when it's warm. Okay, why warming is because ammonia gas is rather soluble in water. So by warming, you help to liberate the ammonia gas, so you can test for the presence of ammonia gas. You can use this acronym, always answer someone who asks. Okay, alkali plus ammonium salt forms salt, water, and ammonia gas. So if you look, if I use the alkali sodium hydroxide and the ammonium salt, ammonium chloride, you will get sodium chloride. Okay, so the front part of the salt comes from the alkali, the back part comes from the ammonium salt. The hydroxide becomes water, and the ammonium ion becomes ammonia gas. Okay, so pause the video, try to write the chemical equation now. Alright, so in the exam, right, if you exceed the line, make sure that your product still remains somewhere on the right hand side of the arrow. So don't go to the next line and write it below on the left hand side. To test for ammonia gas, we can use a moist red litmus paper. After warming, remove the test tube from the flame, then insert the litmus paper to the mouth of the test tube, and then it should turn blue. The last kind of reaction that alkalis undergo is this thing called precipitation. So in chemistry, the word precipitate means it is a solid that is formed from a solution. As you know, alkalis contain hydroxide ions, and many metal hydroxides are insoluble in water. So if we mix an alkali with a salt solution, chances are we can get a precipitate to form. Okay, so let me show you some example. Okay, maybe let's do the one over here. Let me get some copper 2 sulfate. Some copper 2 sulfate here. And we will add dropwise some sodium hydroxide. Okay. Okay, do you see some solid forming? Yeah. So over here, you can see on the sides, okay, it's a solid precipitate of copper 2 hydroxide. So in precipitation, right, how it works, if you notice, let me shade it for you. Sodium hydroxide, copper 2 sulfate. Notice they exchange partners. You will get copper 2 hydroxide and sodium sulfate. Okay, so they rearrange like this. We will cover more of such reactions in the next chapter of qualitative analysis. Alright, pause the video and try to write the chemical equation and the ionic equation for this reaction. Okay, this is what you should get. So if you were to zoom into what is happening is that your copper 2 ions are reacting with the hydroxide ions to form a precipitate of copper 2 hydroxide, leaving behind the sodium ions and the sulfate ions. Alright, this part of the notes is optional. You can go and find out what are some of the uses of alkalis in your everyday life. For students taking G3 chemistry, you will be required to know the strength and concentration of alkalis, how it affects the behavior. So again, to reiterate what we have covered before in terms of acids, we can look at the concentration of mobile ions or the concentration of hydroxide ions, depending on what we are looking at. So if you are looking at chemical reactions, it depends on the concentration of hydroxide ions. If we are looking at electrical conductor, we are looking at concentration of mobile ions. So like acids, how strong an alkali is refers to the extent of dissociation or ionization. So an example of a strong alkali will be sodium hydroxide because it dissociates completely in water to give a high concentration of hydroxide ion. A weak alkali, on the other hand, dissociates partially in water to give a low concentration of hydroxide ions. So again, we use these double-headed arrows. So if you were to look at the solution of aqueous ammonia, most of it will be ammonia molecules, and a small proportion of them exist as NH4 plus and OH minus. In older textbooks, they may refer to aqueous ammonia as ammonium hydroxide. Okay, but in Singapore, we use the term aqueous ammonia instead. Alright, and like acids, how concentrated an alkali is would affect the concentration of OH minus as well as the mobile ions. So both of these affects the electrical conductivity as well as the rate of a reaction. So you remember that acids have monobasic and dibasic acids. So is there an equivalent for bases? So there isn't any of such things mentioned in our textbook, but if you look at bases, right, for example, sodium hydroxide and calcium hydroxide, you can see that one formula unit of NaOH gives you only one OH minus, whereas one formula unit of calcium hydroxide gives you two OH minus. So it's similar to the concept of your monobasic and dibasic acids. Okay, but for alkalis, because they are ionic compounds, we cannot say each molecule, we say each formula unit. Alright, so let's summarize this video before we end. We have covered the physical properties of bases and alkalis. Can you recall some of them? So they have a bitter taste, soapy feel, conduct electricity when dissolved in water, and turn your red litmus blue. Okay. What about the chemical properties of alkalis? Can you recall the three of them? So the first would be neutralization, acid-base, salt water. The second would be alkali and ammonium salt, giving salt water and ammonia gas. And finally, we learnt about precipitation, where a solid metal hydroxide is formed when you add an alkali to a metal salt solution. So that's all for this video. I'll see you all in class.